You're welcome to another video of the course IPv6. In this section, I'm going to introduce IPv6 Neighbor Discovery Protocol or NDP. We will just have an overview of the message types and applications. Message types including router solicitation and router advertisement, and also neighbor solicitation and neighbor advertisement. And applications including router and prefix discovery, which we have a little discussed in the previous sections, address resolution, duplicate address detection, and neighbor unreachability detection. We will have just an overview of NDP protocol, but in the upcoming sections, we will demonstrate and be more deep into details of each message types and applications. This figure shows an overview of IPv6 NDP messages and their application. As you can see, I've divided NDP messages in two sections, router solicitation and advertisement, which have its own applications, and neighbor solicitation and neighbor advertisement with its own applications. In the previous sections, we have demonstrated these two topics, and we have seen how these dynamic addressing methods rely on router advertisement messages, since hosts can learn prefix and prefix lengths through the router. And with learning prefix and prefix lengths, they are able to obtain their own IPv6 address through a Slack mechanism. And we have also seen how default gateway in IPv6 can instruct clients through router advertisement if they are allowed to obtain IPv6 address through a Slack or DHCP process. In IPv6, we know that always default gateway is learned through router advertisement message and not through DHCP protocol. There are also some other applications that we have not discussed in the previous lessons, but we will discuss in upcoming lessons, including MTU, uplink, and gateway priority, which we will discuss later. There are some other applications in IPv6 rely on NDP messages, including neighbor solicitation and neighbor advertisement. The most important application of these two messages, address resolution. As you know, address resolution in IP version 4 is handled through our protocol, but in IPv6, it is handled through these two NDP messages. Other applications include duplicate address detection when an IPv6 host receive or obtain an IPv6 address through a Slack or DHCP method must make sure that the address is not duplicate and then is allowed to use the IPv6 address. This is done through sending neighbor solicitation and neighbor advertisement messages, exactly what is done in address resolution protocol. That means we will send a neighbor solicitation for the IPv6 address. If there is a reply for that address, that means that address is duplicate. Otherwise, we are allowed to use that IPv6 address. Or neighbor unreachability detection is the other application of these two NDP messages, in which IPv6 host can track its neighbors to make sure that the neighbors are always available. For example, as a router, when you know that your next hop is not anymore reachable and they are unreachable, you can easily remove any routes with this next hop IP address from the routing table, so the resources will be not wasted with sending packets through the next hop which is not reachable anymore. As you can see, NDP protocol in IPv6 plays a critical role in the communication in a way that the communication is not possible without this protocol. An interesting point about IPv6 NDP protocol is that it is carried over ICMP version 6 as it is displayed here, IPv6 header and then ICMP version 6 header, and then inside ICMP version 6 we have different message types, including these four NDP messages: router solicitation, advertisement, neighbor solicitation, and neighbor advertisement. And in this table, you can see For each of these messages, the ICMP type is 133, 34, 35, and 36 for these four messages. What is interesting here, as you know, as I have discussed earlier, address resolution in IPv6 is handled through neighbor solicitation and neighbor advertisement, which is handled through ARP protocol in IP version 4. That means in IP version 4, address resolution is handled in layer 2 over Ethernet with sending ARP request and ARP reply packet. But in IPv6, even address resolution is handled through ICMP version 6 messages. In other words, neighbor solicitation and neighbor advertisement with message types 135 and 136. This table also shows an overview of NDP messages and their applications. Router solicitation is an ICMP version 6 message with type 133, which is always sent by a client to receive prefix and gateway information through the router. So router solicitation is sent through the client to the destination IP multicast address FF0, 2, and 2, which points to all routers. So all routers will receive the router solicitation messages and they will apply with router advertisement. Router advertisement is always sent through the router when we enable IPv6 routing every 200 seconds or whenever router receive a router solicitation packet. The message type is 134 and the source of the router advertisement is link local address of the router and destination address is multicast address FF021, which points to all nodes in the network. That means all nodes in the network will receive information related to the prefix lengths, and default gateway, and some other information that we will discuss in upcoming lessons. And notice that source IPv6 address of both router solicitation and router advertisement is link local IPv6 address of the sender. That shows the importance of link local address in IPv6. And two other messages, neighbor solicitation and neighbor advertisement with message type 135 and 136 are used mostly for address resolution and duplicate address detection. That means when we have an IPv6 address, but we need to have also the MAC address, we will send a neighbor solicitation packet for that IPv6 target address, and it will be sent to solicited node multicast address of the node. That means unlike ARP packet, which in IP version 4 is broadcasted inside the network, neighbor solicitation will be mostly sent to the target node. And target node will reply with its own link layer address or MAC address. The combination of these two messages, neighbor solicitation and neighbor advertisement, can be used not only for address resolution, but also when we need to make sure if an IPv6 address is unique or duplicate, or when we want to make sure if a neighbor is still reachable or unreachable, which is called neighbor unreachability detection.